things that we have to deal with. Hello, everybody. Thank you for taking time to attend this talk. My name is Shri Prasanna, Shri as in Sri Lanka, and I'm a software development manager. I work for Worldpay UK, and I'm used to be based in London, but I am currently based in Cambridge. And this talk is about it's titled SSO using OAuth, Proxy, and ADFS. I would more call it a better title would have been my experiments with Golang. I'll explain the requirements and go from there. We'll talk about the requirements that we were given about a year ago, and the solution that we formed and the architecture that we came out, we identified, and the tool or library that we chose to help us deliver the requirement, and what we did with the actual library or tool, and the issues that we ran into and the performance factors that we had to consider. The requirement was that we were building a very simple, I wouldn't call it very simple, a web-based model-based predicting platform. And we were building a web-based capability which would provide reporting abilities and also administrative abilities on the model generation engine. So we had roughly, I would call it an anomaly detection system. And the internal business users wanted a way of managing the engine and pulling out reports and correcting the engine parameters as and when required and things like that. And so we had a team of JavaScript developers who built the front end for us, and who were building the front end for us. They are still working on it with new versions coming out. And so it was built using AngularJS. It was a single-page application, and we had C# developers who were building the actual API that was sitting behind it. And the requirement was to enable access to this to Worldpay internal stuff only. It was hosted on the internal platform, so there was no way anybody external could access it, to be honest. But there were different departments who were wanting to use this platform, and within the different departments there was a need to authorize access to a specific particular function. For example, if somebody's able to pull out a report, he may not be able to correct the parameters of the actual engine itself, and vice versa. So there was a requirement to implement authentication, and there was a requirement to implement authorization as well. And we looked at a couple of solutions, and since Worldpay used or still uses Microsoft Active Directory, it was internally hosted. Now it's cloud hosted. We identified that building something on top of Microsoft Active Directory would be the easiest solution. Then we ran into a couple of hurdles, and so we initially agreed that we will implement a single sign-on rather than having a custom username password managed within the application itself. It has its own advantages that you don't have to manage. The number of passwords that you have to remember is less by one. And Active Directory groups, which are centrally managed within the company, can be used to authenticate users and to authorize users as well. And yes, so Active Directory groups can also be used for enabling role-based access control. And we had, about a year ago, the only version of Active Directory that was used was ADFS version 2, which comes on top of, which comes along with Windows Server 2012. It's not the latest. It wasn't the latest the last year, but that's what we had. And ADFS v2, as I would refer to, supported just one authorization grant flow. So as part of OAuth 2, there are a couple of grants that you can implement based on your requirements, whether you are building an internal application or a native application or or a web-based application. And the predominantly common one was the authorization grant flow, and that's what ADFS version 2 supported. ADFS version 3, which came out as part of Windows Server 2016, supported more than that. It supported, I think, 3 or 4 grant flows, but we didn't have the luxury of using ADFS v3.
The question, what does ADFS stand?
Active Directory Federation Services. And so the in a single page application, which is primarily running in the JavaScript, built using JavaScript running in the client side, we weren't very confident in using authorization grant flow, but that's what we were given with. We would have chosen, I would have preferred an implicit grant flow, which is more tailored towards native applications and JavaScript-based applications. That's my understanding. But that's what the authorization grant flow was, the only one that was available as part of ADFS v2, and that's what we stuck to. And yeah, why did we choose OAuth 2 and not something more elaborate, more versatile like OpenID Connect? Because or SAML, any Microsoft product has support. I would say any Microsoft support product. ADFS comes with support for SAML-based authentication, and SAML is quite verbose, built on XML, and configuring it was easy, but making it work with web-based applications and REST APIs was not very easy, and so we chose to use OAuth 2. And OAuth 2 works very nicely with JSON REST APIs and single-page applications. And we didn't opt for OpenID Connect because ADFS v2 didn't support OpenID Connect. It was as simple as that. Version 3, which is part of Windows Server 2016, supported OpenID Connect. But yeah, that's the constraints that we had to work with. And so when could use a whiteboard to draw a little diagram, but it's all right. So oh, thank you.
I'm not sure it's going to stay. If you don't mind using like the upper half.
Oh, perfect. That would work.
This in the way. Perfect. Okay.
Oh, okay. Could use a pen. So we identified that we wanted to segregate authentication, authorization, and the actual one thing to mention that I forgot to mention is the entire platform was built as a bunch of microservices. So we had microservices responsible for reporting, microservices responsible for model management, microservices responsible for a couple of other key features. And so to fit a solution, to make a solution which fits in the microservices architecture, we decided that we will have microservices exclusively for authentication and authorization purposes. We could have, so the actual, if the single page application was hosted as a JavaScript application, so we had one service for model management, and we had another service for statistical analysis, and so to fit with, and a few more microservices. And to fit with this particular model, we identified that we will build, we initially started with the assumption that we will build 2 separate microservices, one responsible for authentication and one responsible for authorization. And but this particular model didn't work well because we had one service which was providing ADFS, which was sat here, had to provide both capabilities, and we found it to be easier to have one microservice which would provide both the capabilities. And then we thought we would build a service like this on our own. But then after doing a little bit of research, we ran into this particular, we identified that Bitly had started work on a Golang-based project available on GitHub called OAuth Proxy, which would pretty much do what we wanted to do. And this particular platform wasn't supporting ADFS as an ID provider, but it was an extensive. It was built on a model wherein you could extend it, customize it to meet your own requirements. It already OAuth 2 already supported a couple of OAuth providers like Google, GitHub, and OpenShift container platform, but just that it didn't have an extension for Microsoft ADFS. And it was and the licensing model was quite nice, and it supported OAuth 2 and OAuth OpenID Connect as well, and the application architecture was quite well defined. And simply we didn't want, as I mentioned, since there was something that had been developed by an organization, it was used by quite a few people. We didn't want to start something from scratch. So since it was already there, we thought we will continue the work, extend it to meet our requirements. And it is quite lightweight, and it is stateless in its implementation. So it doesn't rely on any database. It has its own pros and cons. This particular option has its own pros and cons. I'll explain it. And it works quite well with nginx as an auth request module, which is quite powerful as well. So we had an nginx implementation which was hosting all these microservices, or fronting all of these microservices, doing things like SSL offloading and things. So we found it quite convenient to have a module or a service which can act as which can be connected to nginx as a auth request module. So that was quite useful, and it was quite simply feature rich. It had quite a lot of features that anybody could use out of the box, or if they want to extend it to provide support to work with other ID providers like Microsoft ADFS. We could easily look at the documentation, look at the code, look at the tests that have already been written, and extend it as required. So those were the reasons why we decided to use OAuth Proxy, or OAuth 2 Proxy as it is called. And here's a diagram explaining the actual application architecture itself. So if OAuth 2 Proxy works alongside nginx, or it could work separately on its own. We chose to implement the first model because the nginx implementation for this particular project was sort of out of our control, and so we decided to choose the model on the left-hand side, architecture on the left-hand side, wherein OAuth 2 Proxy receives every request after nginx does the SSL termination, and then any upstream microservice or HTTP service like one of these is secured by OAuth 2 Proxy, and it works alongside auth provider. In this case, it happens to be Microsoft's Active Directory. Right, and so why did we choose? The next slide is titled "Why Golang?" or "How did Golang feel?" So after choosing to use this particular product, we ran into a couple of issues. But first, I'll go over our experience in using or extending this particular microservice or application that was built in Golang. We found there were 3 developers within the team who worked on this particular extension, and we found Golang as a very simple application compared to other applications like C# or Java that the other microservices were built on. And so the learning curve was not so steep. The documentation were quite friendly, and the convention over configuration is something that we have known in known to be adopted in quite a few programming languages, but it was quite well used within Golang as well. So any test that you would want to write, you stick it in a file named component_test.go. Then if you run go test, your tests are automatically run. That's nice. And other powerful, simple but quite friendly features that we found very useful were compilation failures when there are unused variables or imports. So that was quite useful. As in, based on my experience on other applications built on other programming languages, when a code comes in for a code review as part of a pull request, the number of variables or imports that I've encountered, which literally are not being used within the actual application themselves, are sometimes quite a lot. And there are developers who don't really appreciate the value or the cost of having these unused imports. Obviously, compilers are smart enough these days to accommodate requirements like that, to cater to handle situations like that. But Go compilation would fail in a scenario like that. We found it to be useful. And the idea of structural typing was quite useful as well. And other little features, like if you want to ignore the output of a particular parameter or a function or a method, using underscores was quite useful. And functions returning multiple values was a feature that is in a way available in programming languages like C#. You could have a tuple, but the support in Golang was much better, quite easy for a developer to pick up and use. And so these were some of the key features of Golang that we found to be quite useful from a developer standpoint. And so what did we actually do? We extended the open source version of the actual OAuth to Proxy that's available on GitHub, and adopted to use the authorization grant flow owing to ADFS limitations. And the scripts that are provided as part of the GitHub repo to compile and test and build the artifacts weren't very Jenkins friendly, or at least weren't very our Jenkins friendly, I should say. So we had to modify all of that to make it to work to suit our internal requirements, and that's pretty much it. I will quickly jump into showing a picture or a workflow or a sequence diagram, I should call it. Yes. So a typical flow is when a client makes an initial request to access one of these microservices, and since OAuth Proxy is sitting in front of any of these, all of these microservices, OAuth Proxy would request or validate if a particular cookie is present, and if the cookie is not present, which is the first case here, there is a redirection to the ID provider, which is Microsoft ADFS in this case, and the user will be required to validate himself. He'll be required to authenticate himself against Microsoft Active Directory. It could happen using Microsoft Active Directory's form-based interface, which is provided by Microsoft ADFS itself, or if you're using one of the Windows terminals which are part of the infrastructure, the integrated authentication would kick in, and at that point in time, ADFS would be able to provide an authorization code to the designated redirect URL, and that authorization code can be used by the OAuth proxy to obtain an auth token. And once the auth token has been obtained, then the access for the client to the actual protected resource is granted. And so in that, at this stage, OAuth proxy has the capability to pass any parameter that it has retrieved from ADFS to the protected resource itself, be it the username and any other attributes that it has retrieved from ADFS. And the response to be sent is processed by the protected resource. And when the response is forwarded to the client, the user information is encrypted in a specific cookie called OAuth Proxy, not surprisingly, and then the normal operation could continue. So assuming the proxy is present, the cookie is present, there's a very quick check that our proxy would undertake to identify to validate the contents of the cookie, to see if it has not expired, and if it has not expired, then it will forward the request on to the protected resource, and the response will be redirected back to the client. So that's a very simple sequence diagram explaining how OAuth Proxy works. And right. So while working on this implementation, we ran into quite a lot of issues, not surprisingly. And the first issue was support from internal architectural community. Obviously, you try to introduce a fancy programming language like Golang in an organization like Worldpay. Then the first thing is, can you not do it in Java? We have built 80% of our architecture systems using Java. Why can't we build this using Java? And questions like that. And questions around hosting capabilities, blah, blah, blah. So there are quite a lot of questions. And the second bigger concern from a developer perspective was support from Bitly, the original authors of the particular product, was lacking. I think we started working on OAuth 2 Proxy back in February 2018, and by then Bitly had stopped enhancing the actual product itself. They stopped contributing to the actual open source product itself. Then the question of if there is a big problem, then we just relying on Shri and his colleagues to fix the problem, because it's not actively being enhanced by the community. So that was a big problem. And using cookies as a JWT store was equivalently a bigger problem. So if I quickly jump back to the actual sequence diagram that I showed you earlier on. So in this particular step, when the cookie is sent back to the client, which is the browser obviously, it is required to hold all the user information, and the user information would be used, the user information are the parameters that the actual protected resource would require to identify who the user is and what are his permissions. For example, basic details like usernames and email addresses would be held. Alongside that, the Active Directory groups that a user is part of, which are quite a lot in number, to be honest, because any person in that company would be part of at least 20 Active Directory groups. And so we are at OAuth Proxy, the very basic version, the very first version that we put out, would retrieve all the user groups from Active Directory, put all of them in a JSON payload, try to encrypt it, and put it in a cookie. Obviously, a browser cannot handle a cookie of a size like that. And so that had some unexpected consequences. And we worked around it by enhancing the configuration in Active Directory itself to return the specified number of groups only, or the groups that we are interested only. So there is ADFS supports a feature like that. So we were not just returning all the Active Directory groups, we were able to say return these groups only, any group starting with this particular character or whatever. And that reduced the size of the payload that's coming back from Active Directory, and so the size of the cookie reduced as well. But still, that doesn't. It's like a ticking time bomb. At some point in time, if this system becomes big enough that it deals with 30 or 40 active directory groups, and if there is one super administrator who has access to all the groups, then yes, we will run into the same problem. So that is definitely an issue that we couldn't work around. And so if comparing a product like this to any other commercial off-the-shelf product that's available in the market, a better implementation would have been to use a backend store where all of these user information are held in an encrypted or in an unencrypted format, and a hash of that is produced, and the hash is held in the cookie. So the hash size wouldn't be too big, and at every time the request is made to the proxy or proxy, the cookie can be, or the hash in the cookie can be used to exchange for the actual user information, and then use that for validation or whatever purpose it is. But OAuth 2 proxy wasn't built using that mechanism, and we didn't want to extend it to that level. And yeah, that's very similar to what I've mentioned here. ADFS version 2's lack of support for OpenID Connect was also not very helpful, and we ran into issues like creation of huge cookies owing to the above two. We worked around that. And another big problem was Golang toolset didn't really work well behind our corporate firewall. For example, very simple operations to compile and package ran into a lot of issues because access to GitHub from our development network was curtailed to a big extent. And so we had to work around it by downloading the relevant packages from HTTPS and then sticking it into local repositories and then working around it. So it wasn't very, very friendly. It would have been very nice if Golang toolset supported HTTPS-based source code retrieval. I know it comes with its own flaws, but using the Git protocol was the problem. I'm sure other organizations don't have a similar problem, but yeah, we had this problem.
Did you consider using modules? Is there some caching that can be done there? I think Go has modules now, but it's fairly new.
Oh, so we used version 1.9 of Go, and I didn't know that modules was.
They came in 11. So.
Oh, okay. Oh, right. Okay.
So the new module stuff has the ability to effectively have the equivalent of your Go's version of NPM repository, but you can have the bits you care and trust inside your firewall, and they effectively can be copies, cached, pinned versions internally.
Oh, okay.
Or overzealous IT groups.
Okay. And one feature that would have really helped along this module subject is we use Nexus for our as our package manager internally. And if there was some sort of a library or a tool chain that would work alongside Nexus, because there are multiple developers trying to download the same set of libraries, and if Nexus was used, was made usable, then it would have been a lot easier as well as a local package manager rather than having to go get it from GitHub all the time. We could have built or extended tool chains to meet these requirements, to get it from GitHub, chuck it into Nexus, but yeah, we didn't take the time. We were a bit lazy. And yes, performance factors. So the application, we didn't test the microservice for high scalability because we currently have about 300 odd users on the platform, and it runs on OpenShift. It's not heavily used, so we didn't validate it for performance considerations. That's all. And I think that's it. It was short. Thank you. Any questions?
How many copies do you run then? Did you run multiple copies?
Yes, so we deployed it on OpenShift, and so based on the load conditions, OpenShift would run 1 or 2 instances. So we chose to run default 2 instances because we had 2 data centers, and we wanted to run it in 2 instances.
How did you persuade your enterprise overlords that Go was good?
As in, the benefits of Go, which were being able to compile for multiple architectures from one set of tool chain without having to recompile it in multiple setups, was one of the reasons why, was one of the benefits that we looked at, or our enterprise guys looked at. And the other factors included support from the community as well. There was this concern on adopting possibly including libraries which are developed by third-party developers, which could be malicious. So we ran into an issue around one node package, npm package, which had some malicious content in it around June, July last year. And that's when conversations on, oh, you're using Golang and the packages that you're referring to are from unsolicited third-party developers, and questions like this came up. So we use a specific internal platform, not internal, but an external platform called Checkmarks to run security scans and vulnerability scans on all our libraries as part of our CI/CD pipeline. And so we agreed that we will get our applications run through Checkmarks, and that gave the architects or the enterprise guys additional confidence that, okay, we're not trying to do anything crazy, and whatever we are trying to do is validated by one of their approved platforms as well. So that gave them some extra confidence.
Would you write anything else in Go?
So we have one another application that's currently hosted in AWS. I'll talk about it separately, but it is for a niche product that Worldpay have produced, which is a mobile-based payment, a POS terminal, and that currently requires a lot of security checks to be performed on it, and these security checks need to be captured somewhere, reported on a regular basis for the likes of Visa and MasterCard to triage and look at it. So in this particular application architecture for the mobile POS, we have built a root evil detection service. We also call it RED service. So it's primarily used to interrogate the state of a mobile device, Android device primarily, on a constant basis, and then identify if there is any vulnerability. For example, has the device been rooted? Has the operating system been tweaked in any way? Has the state of the application or the platform changed in a specific way? So these kind of validations are constantly run on the actual mobile device itself. And so we have this Golang-based service, which is used to facilitate all these validations. That's another service. These are the only 2 services, as far as I know, are built on Golang within Worldpay. There could be others, but I'm not aware.
Cool.
Did you have any problems with performance, or the garbage collection stops, or?
No. So we didn't do any profiling on this particular application because we were not expecting a lot of users on the actual application itself, and our Kubernetes OpenShift implementation would automatically take care of. We had limits configured on the actual microservice itself to ensure that if it goes beyond 1 gig or whatever limit it is, I don't remember, it'll automatically kill the microservice and then restart. And since it was stateless, so we didn't have a lot of issues around performance as well.
Did you do much around, so it's just the auth, the proxy part that you kind of...
Yes.
Did you have to add any kind of metrics or observability features to so you could actually track what it was doing?
So so there are general metrics that are captured as part of our OpenShift platform itself to identify factors like how much is the memory threshold and things like and parameters like that. So those were common for any microservice deployed on our OpenShift platform, and even OAuth Proxy came under that particular monitoring. So we didn't build anything explicit for this. Are there any specific? You guys have apparently built more applications on Golang. If this turns out to be an application requiring a million users or tens of thousands of users, what sort of performance considerations or more monitoring should we be looking at? Can you recommend?
I remember a talk by somebody about Prometheus.
Yeah, so I gave a talk last month about adding Prometheus metrics to a Go program.
Oh, okay.
So if you need to expose metrics about the Go runtime inside your application, or application-specific metrics that you're tracking for your own use inside the application, then Prometheus is one way to do it.
Okay. Oh, nice.
That just basically collects the metrics and exposes them through an HTTP endpoint.
Okay.
And then they can get scraped by a simple time series database for whatever you want to do with them.
Okay. Okay. So we use sysdig for monitoring purposes. Okay. I'll take a look at the talk. I think the video is available on the.
It is, yeah.
Yes. Thank you. I'll take a look.
What is it you use?
Sysdig.
Which I'm not familiar with.
So it's for a sort of low-level Linux thing, right?
It comes with nice GUI for monitoring application performance. So
I suspect you'll have to find a way to integrate with that rather than try and add more technology just now.
Yeah.
yes, yeah, quite possibly, correct. Agreed.
Would you? I assume you've your changes were put back into the project.
So the reason why our changes were not put back into the open source project was back then Bitly were not accepting any pull requests into the open source project, and shortly after, I think July or August, the project was marked as read only on GitHub, and then I think in December a couple of other organizations took over the responsibility of maintaining it, created forks out of the initial version, and started enhancing their own versions. And OpenShift contributors also created their own forks and started enhancing it with their own specific requirements or features. So the initial concern that there is nobody supporting this has disappeared because there are other organizations who have taken support of it. So now it is time to provide a pull request for the changes that we have done. Yes.
Would you recommend it to other people to use these forks? Are there multiple forks? Or?
There are multiple forks. There are definitely there are about 4 forks, and the one by the OpenShift developers is currently very specific to using OpenShift as ID provider. They have disabled Google, GitHub type ID providers, which is unfortunate. But there is some sort of there is one fork which I think is referred to as the official fork. So if you go onto the Bitly's website or GitHub website, they have referenced that development of this particular product is discontinued, but any future enhancements should be considered to be part of this particular other repo. And yes, we will make, I think that's recommended repo. Yes, I would definitely say so. So there is somebody looking after it, so that's very nice. And they've made some important security implementations, enhancements to the platform as well, so which is good.
Cool.
I thought I'll give it a demo, but the guys at Azure have disabled some of my certificates, so it stopped working.
Okay. Very good of them. Okay.
Sorry.
Okay, thanks very much.
Okay, thank you. Thanks a lot.